All right, today in Algebra 2, we're going to look at section 3.7, transformations of polynomial functions. Our essential question, how are symmetry and transformations represented in the graph and equation of a polynomial function? After today, you should be able to identify symmetry in and transform polynomial functions. Okay, so let's look at these first two graphs. We have f of x equals x squared and g of x equals x cubed. It says, looking at the graphs above, is the graph of f or g symmetric about the y-axis? Is the graph of f or g symmetric about the origin? So if I look about the y-axis, that means can I fold it over the y-axis and it lay completely on top of itself? So if we look at x squared, if I take a point here, and if I fold this over the y-axis, this is my y-axis, do I land right here? Yes, I do. So f of x is symmetric about the y-axis. If I look at g of x, again, take a point right here. If I fold this graph over the y-axis, do I have a point on the graph over here? I do not. So g of x is not symmetric about the y-axis. So now we're going to look about symmetric about the origin. So right here, so if I take a point on g of x, so if I take this point again, if I rotate it 180 degrees about the origin, so remember one quadrant is 90 degrees, so if I rotate it, okay, here's 90 degrees, here's another 90 degrees, here I am. So yes, g of x is symmetric about the origin. So g of x symmetric about the origin. If I look at f of x, is it symmetric about the origin? If I rotate it 180 degrees, okay, that point would be way down here, which is not on that graph. So x squared is symmetric about the y-axis, and x cubed is symmetric about the origin. So now we're going to talk about even and odd functions. A polynomial function is considered even if it is symmetric about the y-axis. It is considered odd if it is symmetric about the origin. So we look at some examples here. An even function, again, if I flip it across the y-axis, right, that point, directly across that point, and it tells me that f of x is equal to f of negative x, that's even. Odd function, again, I rotate 180 degrees about the origin. I get f of negative x is equal to negative f of x. Neither, okay, so this function here, I can take this if I rotate, if I pick a point and I reflect across the y-axis, no, I'm not on the graph. If I rotate 180 degrees, no. So it is not even or odd, okay? All right. So we're going to now look at identify even and odd functions from their graphs. So use the graph to classify the polynomial function as even, odd, or neither. So again, look at this first one. I can tell that it is not going to be symmetric about the y-axis because I don't have anything in the second quadrant above the x-axis, but I have something in the first quadrant above the x-axis. So I know it's not symmetric about the y-axis. So now I want to check for about the origin. So if I take this point that they gave to me, and this is actually the point 1, 1, if I rotate it, this point is negative 1, negative 1. 180 degrees. Are they both on the graph? Yes. So this is reflection about the origin. So this has origin symmetry. Therefore, it is an odd function. I look at number 2, I can very easily see that if I fold this graph over the y-axis or reflect it over the y-axis, that this entire part of the graph lays on this entire part of the graph. So this is even because it is symmetric about the y-axis. Looking at number 3, this is the point for our reference, 1, 2. This is the point, negative 1, 0. I can tell that it's not going to have y-axis symmetry, so I know it's not even, so I need to check for odd. If I take the point 1, 2 and I rotate it 180 degrees, that is not down here on this graph, so this is neither. Number 4, and if I look at this point and this point, again, I could very easily tell that it does not have y-axis symmetry, so it's not going to be even. If I rotate this 180 degrees, I am right down there on that next point. So this is odd because it is symmetric about the origin. And this last one, again, I can see that I have quadrants 3 and quadrants 4 both below the x-axis. So if I were to reflect it about the y-axis, then I have both points on the graph. So this is going to be an even function, because it's symmetric about the y-axis. So that's how we tell by looking at a graph if it's even or odd. So now let's look at when we just have the equations themselves. Again, it tells me that if f of x equals f of negative x, it's even. If f of x equals negative f of x, it's odd. If neither of those are true, then it's neither. So let's determine if the function is even, odd, or neither without looking at the graph. So what we need to do is plug negative x in for all of the x's and see where we're at. So number 1, f of x equals 4x to the 4th plus 5. If I take f of negative x and I plug in, I get 4 times negative x to the 4th power plus 5. So negative x to the 4th power. Remember, any negative number raised to an even exponent is going to be positive. So this turns into 4x to the 4th and then plus 5. So I got f of negative x was equal to the exact same thing that I started out with, f of x. If f of x is equal to f of negative x, if when I plug in negative x, I get the exact same thing that I started out with, then it's even. So therefore, this is an even function, which means it's symmetric about the y-axis if I were to graph it. So number 2, g of x equals 2x cubed plus 3x. So again, we start out, we plug in negative x for all of the x's. So I get 2 times negative x cubed plus 3 times negative x. Work this out. If I take a negative number and I cube it, I'm going to get a negative number back. So this would be negative 2x cubed, and then 3 times negative x minus 3x. I see I did not get the exact same thing back that I started out with, so I know it's not even. So then I'm checking for odd. Odd says if f of x is equal to the exact opposite, all of my signs change. So that's negative f of x, then it's odd. Did all of my signs change? Yes. So here, g of x was equal to negative g of x. Therefore, it is odd. If I were to graph this function, it would be symmetric about the origin. Okay, number 3. F of x equals 7x to the 5th minus 2x squared plus 4. Again, we always start out, we plug in negative x. So 7 times negative x to the 5th minus 2 times negative x squared plus 4. Negative x to the 5th, negative number raised to an odd exponent, is negative. So I get negative 7x to the 5th. So right off the bat, okay, I know that this is not going to be even because I know that I didn't get the exact same thing back. Negative x squared is going to turn positive, but then this negative 2 out here leaves it negative 2x squared plus 4. So again, I did not get the exact same thing back that I started out with, so I know it's not even. Not all of my signs changed, so I know it's not odd. Therefore, this is neither even or odd. If we were to graph that, we would not have symmetry about the y-axis or the origin. Let's look at one more of these. Number 4, f of x equals x to the 6th minus 2. Again, plug in negative x. So negative x to the 6th minus 2. Again, a negative number raised to an even exponent turns positive. So this is equal to x to the 6th minus 2. The exact same thing that I started out with. So f of x is equal to f of negative x. Therefore, it is even. Right. The last thing that we're going to look at today is graphing transformations of cubic and quartic parent functions. So it says, how do the transformed graphs compare to the graph of the parent function? G of x equals 3x to the fourth minus 18. Our parent function is going to be g of x equals x to the fourth. To make an xy table of this, I'm going to pick the numbers we always pick, -2, -1, 0, 1, and 2. I plug in my x's, my y values, so 0, 0, 1 to the fourth power is 1, -1 to the fourth power is also 1, 2 to the fourth is 16, -2 to the fourth is 16. So I see that this would be an even function, the parent function, x to the fourth. So now I want to identify the transformations. These transformations, the nice thing about transformations of cubic and quartic, they're the exact same transformations, the rules that we learned with all of our other graphs when we were doing quadratics and all of our parabolas. So I don't have any parentheses with x, so I don't have any shifting left or right. I have that number 3 out in front. Okay? So remember the number 3, if my absolute value of a is greater than 1, then this is a vertical stretch. So it's a vertical stretch. Then minus 18 at the end takes the graph down 18. So if I want to graph this, my new XY table, I did not have any parentheses, so my x's stay the same. So I'm still going to have -2, -1, 0, 1, and 2. My y, the stretches and shrinks or compressions. Okay, so, and remember, if it's a vertical stretch, then it's a horizontal compression. Okay? So I would have 3y minus 18. So if I come over here to my XY table, so I start out with 16. So 16 times 3 and then subtract 18 gets me 30. And I'm going to have the same thing down here. I could plug in 1. 3 times 1 is 3. 3 minus 18 gets me -15. So this is also going to be -15. Plug in 0. 3 times 0 is 0. 0 minus 18, -18. So I'm going to graph that. And again, I'm going to graph my new XY table. Let's see, let's go by 2's on our y-axis. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 0 or -18 right here. At -1, I'm at -15. So -1, we're at -15 right here. Same with +1. I'm going to do by 2's going up as well. So 2, 4, 6, 8, 10, 12, 14, 16. So my 30 is going to be way off my graph. So over 2 up, somewhere way up here. So my graph, connect my points, looks like a parabola. Okay? It has a vertical stretch or a horizontal compression. Remember, those are opposites of each other. All right, let's look at one more of those for today. So number 2, h of x equals 5 times x minus 2 quantity cubed plus 4. So let's talk about what the parent function is. So the parent function is h of x equals x cubed. Let's make an xy table of our parent. Again, I'm going to pick the same numbers, -2, -1, 0, 1, and 2. If I plug in -2, -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is +1. 2 cubed is +8. I see that this one is not going to be an even function. It would be an odd function because the parent function x cubed is symmetric about the origin. So come over here. Again, the 5 out front, that is a vertical stretch or a horizontal compression. The x minus 2 shifts the graph right 2. And the +4 at the end shifts the graph up 4. So I want to make my new XY table. This time I have to change my x's, and remember it always comes out opposite, so it said x minus 2, so I put x plus 2. It's going to be 5y plus 4. So I start with my x values of my parent, and I add 2 to all of them. So negative 2 plus 2 gets me 0. Negative 1 plus 2 is 1, 2, 3, and 4. Now I'm going to take my y values, multiply by 5, and then add 4. So negative 8 times 5 gets me negative 40. Negative 40 plus 4, negative 36. Negative 1 times 5 gets me negative 5. Negative 5 plus 4 gets me negative 1. 0 times 5 is 0. 0 plus 4 is 4. 1 times 5 is 5. 5 plus 4 is 9. 8 times 5 is 40. 40 plus 4, 44. These are the points that we're going to graph. So let's see. My graph over here, I've got 2, 4. 1, negative 1. 3, 9, 0, negative 36. So 0, we're way down here. 3, 9. So let's see if I can get 1, 2, 3, up 9. And so connecting my dots, my graph looks something like this. So that's stretched out S. Okay? It's a lot more stretched out because it has that vertical stretch in there. All right, so that's how we graph transformations of cubic and quartic parent functions. Again, what's nice is we already know all of those rules. Okay? We're going to stop there today. Tomorrow we will look at identifying the transformations on a graph and writing the equations, and then applications, which means our word problems. Yay, right? All right, today's homework is going to be in Envision. So log into Envision 3.7. So 3.7 day 1 in Envision. Make sure that you take a screenshot after you've submitted and got your score, and upload that screenshot to the assignment in Canvas.